Let's see this question. So f of x, y, z is defined as x plus y plus z. And subject to, oh, we're missing one line. Right? We want to find extrema, right? Which means the maximum point or minimum point of such function. And subject to this constraint and this constraint. So we want to use Lagrange multiplier method. So Lagrange multiplier method says the gradient of f equals to a scalar multiplied by gradient of g. What is g? We can define x squared plus y squared as a g function. And then we can define x plus 2z as an h function. So g x takes, both of them take x, y, z as input. So Lagrange multiplier is saying if those two functions are subject to f or to be constraints of f, then gradient of f will be a scalar, a real number, multiplied by the gradient of g, plus another scalar multiplied by gradient of h. So what's gradient of f? Gradient f is partial f partial x, which is 1, partial f partial y, 1, partial f partial z, which is 1. So the 1, 1, 1 vector. The number 1 multiplied by gradient g. Gradient g is partial g partial x, which is 2x. Partial g partial y, which is 2y. Partial g partial z, which is 0. Right, plus another scalar, another real number multiplied by gradient of h. Right, partial h partial x, which is 1. Partial h partial y, 0. Partial h partial z, 2. So we have this vector equals to addition of other two vectors by scalars. So we can rewrite this as system of equations. So the first component 1 has to equal to the first component, what's this first component, which is number 1 times 2x plus number 2, right? Number 2 times 1 is number 2. Then the second component 1 equals to number 2y, number 1 times 2y plus number 2 times 0, 1. We don't really have to add 0 to it. You can just ignore the 0. Then the third component 1 equals to number 1 times 0, which is 0. Then plus number 2 times 2, so get 2, number 2. Right? So we have these three, then we want to work with the constraints. So x squared plus y squared equals 1, and x plus 2z equals to 1. Well, let's work with the third equation. Third equation tells us number 2 equals to half. Right? Then we plug in the first equation. Then we get number 1 times 2x equals to half, right? Because number 2 is a half, 1 minus half is a half. Then from the second equation we get number 1 times 2y equals to 1. So if we rewrite the first equation, we can rewrite as number 1 times 4x equals to 1. Right, work with this one. So these two give us, so this one. So this will give us the relationship between y and x. So 2y, we can write as 2y equals to 4x, which means y equals to 2x. Now we're gonna plug into the fourth equation. So x squared plus now y equals to 2x. So substitute 1 into 2x squared equals 1. Solve this equation. We have 5x squared equals 1. X squared equals to 1 over 5. So x equals to plus minus 1 over square root of 5. So square root both sides, right? Square root 1 is 1, square root 5. Now we plug in the value into the last one. So x equals to plus minus 1 over square root 5, plus 2z equals to 1. So z equals to 1 minus plus, right? Because once we switch this one to the other side, it becomes minus plus 1 over square root of 5. But then we have to divide by 2 because it's a 2z. 1 divided by 2 is a half. And this fraction divided by 2, just have to divide by 2 here. So we get 2 critical points. So the first critical point is x value equal to positive 1 over square root of 5. And then y double set y equal to 2x. So y equal to 2 over square root of 5. The z value is a half minus 1 over 2 square root of 5. So this is one critical point. Another critical point is x value equal to negative 1 over square root of 5. And y double set, so it's a negative 2 over square root of 5. The z value is 1 plus, no, not 1 plus, half plus 1 over 2 radical 5. So get these 2 critical points. So which one is maximum? Which one is minimum? Well, the function is defined as f of x, y, z. Just add those 3. Just add x, just add 1, add z. So obviously, we see the first one will be maximum, right? Because the first, so f value of over this x, y, z value will be greater than this one because this will have the first two to be negative. So this will be, this one will give us a minimum, right? So basically this one and f, so evaluate f, add this x, y, z value, we'll just add those 3, right? Well, let's find, right? Let's find the value of it. So f of 1 over square root of 5, 2 over square root of 5, half minus 1 over 2 radical 5. Just add those 3 values. So the first two, when we add, we get 3 over square root of 5. Then plus half minus 1 over 2 radical 5. Then we can multiply 2 over 2 here to have a common denominator. Right, then we have a half. 2 times 3, 6. 6 minus 1, 5. So plus 5 over 2 radical 5. And we can simplify this to be half plus half square root of 5. Or to write as 1 plus square root of 5 divided by 2. Right, do the same thing for the other one. For this one, this will be negative. Negative. Then 1 half plus 1 over 2 radical 5. Also, we add the first two, get negative 3 over square root of 5. Then plus half plus 1 over 2 radical 5. We multiply 2 over 2 here. So we can combine those two terms. We have common denominator, 2 times 3, 6. That's minus 5. So this will get a half minus 5 over 2 radical 5. And we can simplify this to be 1 minus the square root of 5 over 2. All right, so obviously, so this one is the maximum value. This one is the minimum value. So we'll write the max, minimum.